Alright guys, this is your Unit 8 review video. I think I picked a good variety, so I'm just going to get on into showing you which ones we're going to do. Throw that one in there. Right, and that should be it. Alright guys, so starting with some multiple choice practice. Starting with question 3, which of the following gives the correct recursive equation for the sequence? Remember that recursive is 2 parts, and this formula is never given to you on a reference sheet. So right there I can eliminate option 2 because that doesn't have 2 parts to it. I notice that it looks like I'm multiplying by 4 each time, so that tells me it's a geometric sequence. Since I'm multiplying by 4, that's my ratio. So whenever you do a recursive sequence, it's always the first term and whatever's happening to the previous term that gives you the next term in the sequence. So I just said we're multiplying by 4 each time. A sub n minus 1 means the previous term. So I'm taking the previous term, multiplying that by 4, and I know my first term is 9. Okay, so right now I'm eliminating 3 because a sub 1 is 4. So now I'm between 1 and 4. This one's the only one where it's dealing with a sub n minus 1, which is, again, the previous term. So option 1 is the correct choice. For number 5, it tells me the third term in an arithmetic sequence is 10 and the fifth is 26. If the first term is a sub 1, which equation is the nth term? So any number or slot term in the sequence. I like to map this out. So I've got 1, 2, 3, 4, 5. The fifth term is 26. The third term is 10. So in order to figure out the common difference, which I'll need, I just do the slope. So I get 16 over 2, which is 8. So that means that this, oopsies, I wrote 18. 8, I was thinking ahead, because then that means that this number is 18, which means working backwards, this is 2, subtract 8 again, that's negative 6. So knowing it's an arithmetic sequence, this is the formula I have to plug into. I know the first term's negative 6. I know the common difference is 8. Now you'll notice that's none of my options. So therefore, I have to go and clean this up a little bit. So 8n minus 14 is option 2, and that's our correct choice. Okay, next is our mortgage problem. Don't worry, we'll always give you a formula for this. You just have to know how to use it. So Jack and Jill found a home that's for sale for $170,000. They can afford 15% down. So that means how much money they'll pay ahead of time before asking for a loan. They pay to take out a 30-year mortgage at 3.2% interest with we want to find the total monthly payment. So this is the list of things we need to find: the loan size, the recurring payment, the monthly interest rate, and the number of payments. The recurring payment is what we don't know. The monthly interest rate is the percent that they give you as a decimal divided by 12, because this is an annual rate. The number of payments is going to be 360, because it's wait, excuse me. I'm sorry, not 360. It's going to be, well, I mean, it will be. It's 12 because it's monthly payments, but you're doing this over the course of 30 years. So it is 360. I just wanted to show you where I got that number from. Now, as far as the loan goes, if you're paying 15% down first, that means you're still maintaining or owing 85% of the house's original value. So I'm going to calculate 85% of $17,000, which ends up being 144,500. Okay, so I still owe then, or money I still need to get from the bank is $144,500. Now I just have to plug in what I know. So I'm plugging into my formula. Now, you'll notice that I'm leaving that I in fraction form. That's because if I do 0.032 divided by 12, I'm going to get a non-terminating decimal. And that's not going to be as accurate as I like it to be. So I'm leaving it in fraction form. So in my calculator, I'm going to go ahead and plug in the right-hand side. And since I don't have alpha y equals on my calculator, because this isn't a newer model, I have to do the numerator first, then divided by the denominator. So this will take a minute. Okay, so there's my work. So that's going to be this value over here on the right. So I'm going to take this 14,4,500 number, divide that by that answer, and I get 624.91. And that's your answer. All right, the sum of a geometric series with 4 terms and a common ratio of 5 is 1,872. Find the first term of the sequence. So it wants you to find a sub 1. I know n is going to be 4, and I know r is 5. And I know the sum is that number. So this means I'm using my geometric series formula, which is S sub n equals a sub 1 minus a sub 1 times r to the n, all over 1 minus r, and this is on your reference sheet. I plug in what I know. Okay, so I just cleaned this up a little bit. You'll notice that I calculated 5 to the 4th as 625. Okay, so those are relating to each other. From here, I'm going to cross multiply to get rid of the fraction. I'll write it this way. Okay, so now this is the part where students get stuck. They're like, how do I solve for a sub 1? There's 2 of them. Well, here's the good news, guys. The coefficient on a sub 1 is 1. These are like terms. I can do 1 minus 625 because that'll tell me how many a sub 1s I have. So negative 624. So now in my calculator, I take this number, divide by negative 624, and I get 12. And that's your answer. It should work out to a pretty good number. We're not trying to mess with you too much. All right, next problem. Okay, determine if the sequence is arithmetic or geometric. Remember, arithmetic means adding, geometric means multiplying. State the common ratio or difference, then write an explicit and recursive for each. So B, I'm noticing it goes 5, 3 radical 5, 5 radical 5, and so forth. So in order to get from radical 5 to 3 radical 5, you may be thinking multiply by 3. But then that wouldn't make sense to get to 5 radical 5. So now you should start thinking about adding. If I add 2 radical 5. That would give me 3 radical 5. Plus another 2 radical 5 would give me 5 radical 5, and so forth. So therefore, this is an arithmetic sequence. Your explicit formula is going to be a sub n equals a sub 1 plus n minus 1 times d. Okay, and you can leave it like that. That's your explicit formula. Your recursive formula has 2 parts. My first term is radical 5. And then this, oops, I changed my color for some reason. If you want the next term in the sequence, you have to take the previous term and do what to it? Well, we just said if you want the next term in the sequence, you have to add 2 radical 5, so that's all you have to do. Okay. Draw a line there. Those are separate. Don't know why my pen color changed. All right, let's say I want to evaluate some sigmas. Remember, sigma means sum, and another word for sum of a sequence means series. It's the whole unit of S's, sequences, sigma, sum, series. So let's start with something like, actually I'm going to do A for a second just to remind you of how this works. This is your lowest integer value that you're going to plug in. This is your highest. This goes to 2 times 3 squared plus next integer value, 2 times 4 squared plus 2 times 5 squared plus 2 times 6 squared plus 2 times 7 squared. Stop. You'll notice that this is my start value. This was my end value. Plug that in your calculator, evaluate it. Now down at C, it gets a little bit more complicated because I have 2 variables happening. Okay, I got an x and an n. Remember that this means you're plugging in for n. So it says start at 0. Then it says go to 1, because that's the next integer value. And then go to 2. Clean it up a bit. Anything being raised to the first power goes, or to the zero power goes to 1. Anything to the first power is itself. I don't know why I switched that, but I did. And this last part, make sure you're actually multiplying it out. So this is 1 minus 2x minus 2x, which is, or I'm sorry, plus 2x, which is plus 4x, plus 4x squared. And then I still have this stuff over here on the left. My pen color changed again without me knowing, but it kind of worked out for me. Okay, so from there, I combine my like terms and put it in standard form. And there you go. That's your final answer. Okay, so now we're going to go the other way, and I'm going to give you a sequence, and you have to come up with the sigma. So first thing I figure out is if it's arithmetic or geometric. Or neither. Sometimes it's neither. Now, what I'm noticing along the bottom of these is it looks like I'm multiplying by 3. Along the top, it looks like I'm multiplying by 2. So that tells me that this is a geometric sequence with a common ratio of 2/3. So in order to write this as a sigma, close that out. In order to write this as a sigma, I'm going to use the explicit formula of a geometric sequence. The first term times the common ratio raised to the n minus 1. Now, because I'm using the explicit formula, I'm going to start it at n equals 1 and end it at 5 because there's 5 terms in the sequence. Done. Now this one is one that students love to get wrong. Okay? It says the explicit formula of a geometric sequence is giving. What's the first term? Don't write 2050. This is not the explicit form that's on your reference sheet where this first term's a sub 1. This is not a sub n equals a sub 1 times r to the n minus 1. So that is not your answer for the first term. You know how you find out the first term? Just plug in 1. Plug that in your calculator, evaluate it. and you are going to get, and I'm cheating a little bit, 16.4. I didn't feel like pulling it up on my calculator. 16.4. The common ratio is not 1/5. If I manipulate this a little bit and bring the 3 in, what this means is every time n goes up by 1, we are multiplying by 1/5 to the third. Oh my goodness. I keep accidentally opening things with the palm of my hand on this. Anyway, so 1/5 to the third is 1/125. So that's your ratio. So putting it all together, recursive needs two parts. Our first term, which I know is 16.4, and the second part, which is based on the previous term. So if you want using the previous term to get the next term, we're going to take a sub n minus 1, the previous term, and multiply that by 1/125. Now, show you something in the calculator real quick here. Let's say you're doubting all my math here. What's stopping you from plugging this in your calculator? I can go to y equals and do 2050, 1/5 to the 3n, except I'm going to need parentheses here because I have an older software on my calculator. Okay, and you can just look at a table of values. There it is. There's the first term is 16.4. If you're concerned about figuring out the common ratio, just take two terms and divide them. Obviously, I wouldn't use the ones with e's in them because this is going to start to get super small. But if you even wanted to pick some bigger numbers because it's all the same pattern, just pick 2, divide them, and you'll get 1/125. Okay. So let's say I give you an image of a sequence. This is 110, 215, 320. If you pay attention to just the y's, each time I'm going up by 5. Up 5/1, up 5/1, up 5/1. So that's why on a previous problem I said that the common difference is equal to your slope. So in this case, d is 5, which you could have figured out just by doing 15 minus 10 and so forth. If I need to write a formula to model it, I really could do either explicit or recursive. My explicit formula would be the first term, so 10 plus n minus 1 times d, which is 5. My recursive has, again, two parts. A sub 1 equals 10, a sub n is a sub n minus 1, so the previous term, and I'm adding 5 each time. Done. Now, for number 14, these are the ones that kind of stump you guys just because they're in a different notation than we're used to. This is a particular sequence that's been defined using function notation. Okay, so a particular sequence is defined recursively such that f of 0 equals 2, f of 1 equals 2. I want to find f of 4. They give you a pattern here, so I need you to follow the pattern. If I set 4 equal to n minus 1, that means n must be 3. So figuring out the rest of this pattern, f of 4, to figure out f of n, if n is 3, this is just f of 3. So I've got to figure out what f of 3 is. Minus 3 times f of, now I'm doing n minus 1, remember n was 3, so this is 2. So now think about this in the order of the terms given. If I want one term, I'm going to need the previous term, take away 3 times the second previous term. That's the pattern. Now, I don't have the third or the second, or f of 3 or f of 2 for that matter, but I do have 0 and 1, so that means I can find the next one in that sequence. I can find f of 2. So following the pattern, this is the previous minus 3 times the second previous. And now it's just a plug and chug. I know that the first term is, or f of 1 is 2. I know f of 0 is 2. So I do 2 minus 6, which is negative 4. Okay, so now I go on to the next thing, because now I can find f of 3. I just keep building. This is the previous term minus 3 times the second previous. I plug it in. Okay, f of 2 I just found was negative 4. F of 1 is 2. That's negative 10. So now lastly, I can figure out f of 4. As I said before, this is f of 3, which I just found is negative 10, minus 3 times f of 2, which I found is negative 4. So this then goes to 2, because that's negative 10 plus 12. So 2 is your final answer. Now, this is a recursive sequence, because in order to figure out the fourth term, I had to figure out all the terms before it. So that's the difference between recursive and explicit. Explicit formulas allow you to figure out whatever value you want just by plugging in a value for n. So in the example in 13, if I want the 100th term, no problem. Just plug 100 in for n. But if you're going based on a recursive model like 14, I am not going to know f of 100 without figuring out f of 99 and f of 98 first. So recursive can be very tedious. All right, next, number 15. What is the common ratio of a geometric sequence where a sub 2 is 42 and a sub 6 is 8750 divided by 27? All right, let's map it out. In a geometric sequence, you are multiplying by r each time. So, this next slot would be 42r. If you multiply by r again, that would be 42r squared. Multiply by r again, that's 42r cubed. One more time, this would be 42r to the fourth. These things need to be equal to each other. So that's how I come up with my equation. 42r to the fourth is equal to 8750 divided by 27. Okay, now I'm going to go ahead and divide both sides of this by 42. Okay, got a fraction. So 625 over 81. And then I'm going to raise both sides to the 1/4, or take the fourth root. Okay, now if you know your perfect fourths, I guess you could say, the fourth root of 625 is, probably you guess it, 5. And then 3 to the fourth gives you 81. Okay, so your scale, I almost said scale factor because of geometry, excuse me. Your common ratio is 5/3. So now I'm going to use this to figure out the first term. So, going backwards, if I'm multiplying by 5/3 going forwards, going backwards I'm multiplying by 3/5. So a sub 1 is going to equal 42 times 3/5, which gives me 25.2. And that's your first term. Okay, let's say you know the common difference of an arithmetic sequence is -2, and the first term is 13, and the last term is -183. How many terms are in the sequence? I'm going to use my explicit formula to help me here. I'm going to call a sub n -183. I want to figure out at what point, so what n value, what slot in the sequence, I'm going to get that particular term. They tell me my first term is 13. they tell me the common difference is -2. Notice how I use parentheses around the -2. That's important. If you don't, it's going to look like subtraction and you will mess up. So first thing I'm going to do is subtract 13. Okay, so I got -183, subtract 13. Okay, then I'm going to divide by -2. So I have 98 equals n minus 1. So that means n must be 99. So this must be the 99th term in the sequence. So what if I want the value of the 10th term? Well, now I can use an explicit formula. I know the first term is 13. I'm going to plug in 10 for n. And I know my common difference is -2. So all I'm doing is plugging in to this formula right there. I go ahead, I evaluate it, and I should get -5. Okay. What is a formula for the nth term of the sequence b below? Okay, well, I'm noticing that I am adding 2 each time, so that means it's arithmetic. So that means that I can write this as a sub n equals 10 plus n minus 1 times 2. Okay, I feel like I keep using the same formulas over and over again. Well, because I am, so hopefully I'm starting to sound kind of boring to you, because there's really not much more to this. So now let's say I want to write this sequence using sigma notation. So I want to add them all together. All you have to do is add the sigma, put the explicit formula down below, start it at n equals 1, and then it says for the first 6 terms, so that means 6 is my top value. All right, we're getting to the end here, guys. Keep pushing through. Find the first 4 terms of the recursive sequence defined below. Do not let the notation trip you up. Okay, let me zoom in here. If it will let me. There we go. All right, so let's zoom in. I give you the first term. Let's say I want the second term. According to this problem, if n equals 2, then 2 minus 1 is 1. N is 2, remember? Oopsies. Sorry. I wrote that wrong. 2. Okay? So if I want the second term, I'm going to take the first term, subtract 1. Notice again, because n is 2, when I'm doing minus n, I'm subtracting 2. Okay. Well, what is the first term? They give it to you. So I get -5. Okay, now the pattern continues. If you want a sub 4, you're going to take the previous term and subtract. Remember, it's got to be whatever this n value is. Oh, wait, hold on a second. I skipped a sub 3. Getting ahead of myself. A sub 3 is the previous term minus 3. These are matching. Okay, the previous term I just found is -5. That's a sub 2. Minus 3 is -8. Now I'll get a sub 4. Notice these match. And now we're done. So the first 4 terms are -3, -5, -8, -12. All right, 2 more problems to go here, guys. The sum of the first 8 terms of the series. This is pretty straightforward. Use your sum formula. Okay, so I'm going to use S sub n equals a sub 1, so that's 3, times our common ratio, which appears to be -4. And it says 8 terms, so n is 8. Done. Plug it in. You'll get this number. Now, something I did it with my classes also is I talked about how you actually could write this as a sigma and then plug that in your calculator. So as a sigma, this would be a sub 1 times r to the n minus 1. I'd start n at 1, I'd end it at 8, and then you could plug this into your calculator and evaluate it using your math option 0. Okay? I don't know if one's really easier than the other. I really think that this actually might take more work, but if it occurs to you, great. This is really just using the formula sheet. But if anything, I'm telling you that there are a couple ways that you could write a series. It could be listed using this formula, or it could be written using a sigma. All right, one more formula to go to, or problem to go to. Okay, the sum of a geometric series with 6 terms and a common ratio. Find the first term. Oh wait, I already did a problem like this. So you know what? I'm not going to do it. Good luck studying. Exclamation point, smiley face.